some ideas, and I hope it will be helpful. Okay. So first, my name is Hongwei Zhao. In Chinese, my family name is Zhao, so Hongwei Zhao. And currently, I'm working at Nanjing Agricultural University under the College of Plant Protection, and our department is like yours, plant pathology. And I received my PhD degree in Miami University, Oxford, Ohio, and in botany. And I believe, some of you guys, okay, maybe in future or had already had experience in another country. So I want to share with you some of my experience on that. And now I'm working at Nanjing Agricultural University, and my major or my focal point are plant immunity. Okay, basically how understand how plants are able to against or protect themselves from pathogens. And my focal point are a group of small molecules RNA which do not code any proteins. So we call non-coding RNA. Okay, I'm going to give you some brief examples. And I focused on rice and the citrus, and I also do some fruits like strawberry and the tomatoes. And the overall, my goal of my group is try to developing new pesticides which are precise, efficient, and maybe environmental friendly. Okay. So first, let me introduce a little bit about my research. I'll try to brief because tomorrow I'm going to talk a little bit more, and I just try to give you some conceptual idea about that. First is about rice blast disease. Yesterday I drove by the road M4 route, and I saw some rice pasture over there. And also I tried to develop some management against citrus hornbeam. And yeah, we also try to deal with great mold, which is caused by botrytis scenario. Okay. First, let me introduce what is my topic, which we call microRNA. MicroRNA is very micro. It's only 21 to 24 nucleotides long. Okay. Obvious, with so short sequence, it's impossible for it to encode any proteins, right? So it's non-coding RNA. And how it works? It's working by precisely recognize another messenger RNA. We call it target RNA. Okay. Precise means if you have a residue in this small RNA, microRNA, okay, you have to recognize a U on the opposite strand, right, on the target. If you have C, then you're going to recognize a G. If you have a stretch of 21 nucleotide, then you are going to very, very precisely recognize a stretch of target sequence, right? And that is so unique that pretty much you can design it to any target gene you wanted to bring down. How it's bring down? Because once the small RNA recognize a target gene, what happened next is cut it in between, then degrade it. Okay, so basically, microRNA is a way to suppress gene expression. Okay, that's good enough for my background. Okay, so first we found that in rice, okay, with the interaction with magnetopause already with the causal agent of rice blast disease. Okay, what happened is rice immunity is able to use a group of RNAs. Here I'm presenting 164A. Our evidence shows that many microRNA can do the same kind of job, which is contribute to the resistance to suppress the infection of the pathogen. Okay. obviously those small RNAs or microRNAs positively contribute